Hello and welcome to the Hawkins Contracting Blueprint Reading, Surveying, and Layout Training. In this training, we will go over blueprint reading, surveying, layout, and site strategies. In the blueprint reading portion of the training, we will talk about blueprint basics, scale, symbols and abbreviations, views, lines, shop drawings, details, and specifications. Blueprint basics. This is the title block. The title block will often appear on every page of the construction drawing. The important information inside the title block are the client, the architect's stamp, the designer and architect, the project name, the north arrow, drawing title, the scale, and drawing number. Other aspects of a drawing are the revision block. The revision block is one of the most important sections of a construction drawing. Here you have to look to see if you are working off the most recent version of the drawing. Do not build off any revision other than issued for construction unless told otherwise. Legend. Blueprints are often comprised of symbols and numbers. In order to fully comprehend the drawing, you need to learn the specific symbols associated with each drawing. Scale. Construction blueprints are drawn to scale so it can fit the entire project onto one page. Common scales in our industry are 1 to 100, 1 to 150, 1 to 200, 1 to 250, 1 to 350. Understanding scale. The number after the colon is the multiplier. For example, if you measure 1 centimeter on a 1 to 100 scale, 1 centimeter will equal 100 centimeters in the real world. The drawings must be printed to scale for the scale to work. Always check your scale to a known dimension on the drawing before constructing. There may be more than one scale used in a drawing set. How to read a scale ruler. Find the appropriate scale ruler for the drawing scale. Pick the appropriate side of your scale ruler. Start measuring at the 0, just like you would on a regular ruler. Symbols and abbreviations. Legends are boxes drawn on the drawing to illustrate some of the common or uncommon symbols used. Designers or architects use symbols and abbreviations to limit clutter on the drawing. Views. With two-dimensional blueprints, there are three common perspectives: plan, elevation, and section. Plan. A bird's eye view of the planned work. This perspective allows precise mapping of width and length. Elevation. A view of planned work from the side. These drawings are usually orientated from north, east, west, or south. Composing an elevation map allows for detailed planning of height dimensions. Section. A view of something as if it were cut through. The perspective is generally imaginary and is used to show the inner workings of how something will be built. Here are pictures of each view: plan view, elevation view, and section view. Lines. There are many different types of lines used to create a blueprint: object lines, hidden lines, center lines, extension lines, dimension lines, and contour lines. Object line. The object line is a heavy dark line which identifies the visible edges of the drawn object or surface of an object. Hidden line. The hidden line is used to show features or edges of an object that are not visible. It is a broken line of medium thickness. Center line. The center line is used to locate the center of a feature. It is usually a fine broken line made of alternating short and long dashes. Dimension line and extension lines. Dimension lines are used to show the extent of the dimension. Extension lines are used to extend a point from an object. Contour lines. Contour lines are imaginary lines that connect points of equal elevation. Contour lines always connect, but not always within the blueprint boundaries. More about contour lines. Widely spaced contour lines indicate flat surface. Closely spaced contour lines indicate steep ground. Equally spaced contour lines indicate uniform slope. Take a quick look at this drawing. Here you will see a proposed contour line, an existing contour line, proposed spot elevation, and existing spot elevation. Shop drawings. Shop drawings are often sent by the manufacturer of certain components of a job. You must always build to shop drawings when available, as components are often constructed marginally different than the construction blueprints. Items that usually include shop drawings are bridges, gazebos, precast buildings, site furniture, etc. Details. The details show a more descriptive drawing of particular aspects of the project. Usually these details are not to scale, or NTS. Details show what type of material are used for each part of the construction, the thickness of the materials, compaction density, notes about construction of the particular detail. Specifications. Specifications describe the materials and workmanship required for a construction project. They do not include cost, quantity, or drawn information, so they must be read alongside other information such as quantities, schedules, and drawings. Specifications are project specific. Specifications always overrule drawings. In the surveying part of this training, we will talk about terminology and abbreviations, tripod and laser setup, how to use and set up a field book, using laser to find elevations, as well as laser slope capabilities. Terminology and abbreviations. Station, a precise point from which measurements and surveying are made. Foresight, rod reading taken on a point to determine the elevation of that point, sometimes called the minus shot. Height of instrument, the elevation of the level line sight projected by the instrument when properly set up. Backsight, rod reading taken on a point of known elevation, sometimes called a plus shot. Elevation, vertical distance from a reference point, usually sea level. Proposed elevation, the elevation that is given to you on a drawing. Benchmark, monument or point with known elevation. Tripod and laser setup. First, you need a benchmark, or known elevation. Once you've established your benchmark, set up your laser in an area that you will be able to read the laser line with the receiver when you hold the rod on the benchmark in the areas you are wanting to survey. When setting up a laser to take readings, the tripod leg should be positioned as such as to provide stability and a convenient height. The leg should also be positioned as such an angle to leave the rotating laser in near horizontal position to allow it to self-level. If more than one laser are being used on the site at one time, make sure to set them at noticeably different heights as not to cause nuisance or incorrect measurements. Rod setup and reading. Each square is 1 centimeter. The bottom of the E or 3 is always a 5, either 0.5 meters, 0.15 meters, 0.25 meters, etc. The top of the E or 3 with the line on top is always a 0, 0.1, 0.2, 0.3 meters, etc. A solid beep means that you're on grade on the receiver. A quick beep on the receiver means you have to move the receiver down. A slow beep on the receiver means you have to move the receiver up. How to set up a field book. Field books are used to document different elevations you are surveying. It is important to use a field book in case a mistake is made while surveying, as it will make it easier to see what went wrong. It is also easier to stay organized while surveying if you write down your elevations and calculations the same way each time. Finding your HI, or height of instrument. Once your laser is set up, turned on, and the laser eye is spinning, you are ready to take a rod reading on the benchmark. This is called a backsight or plus shot. Place the rod on top of your known benchmark and move the receiver up and down until it beeps a solid tone. It is important to keep the rod vertically level when taking a shot. Once you have determined the number on the rod, the vertical distance above your benchmark elevation, add that number to your benchmark elevation to find your HI or height of instrument. For example, if your benchmark is 88.7 meters above sea level and your reading on your rod is 3.2 meters, your HI would be 88.7 plus 3.2, which equals 91.9 meters. Finding an unknown elevation. Once your height of instrument is known, the elevations of the other points can be determined from that setup as long as your receiver can see your laser line. To determine the elevation of an unknown point, you will perform a foresight shot or a minus shot. Put your rod on top of the unknown elevation. Move the receiver up and down on your stick until it beeps a solid tone. Once you have determined the number on the rod, subtract that number from your HI. Example, if your HI is 91.9 meters and your receiver on your rod is reading 4.1 meters, you would do 91.9 minus 4.1, which would give you 87.8 meters. Finding a proposed elevation. To lay out a proposed elevation, you will need to subtract the proposed elevation from your HI. For example, if your proposed elevation you're trying to lay out is 89.4 meters and your HI is 91.9 meters, you would go 91.9 meters subtract 89.4 meters, which would give you 2.5 meters. You would then set your receiver to the 2.5 meter spot on your rod, and the very bottom of your rod would be the elevation you're trying to lay out. Laser slope capabilities. These are the two lasers we most commonly have at Hawkins Contracting. The RL-H4C with no screen is a single slope laser. It'll slope up to 5% negative or positive in only one axis. Laser must be properly aligned so that the laser beam is parallel with your desired direction of slope. The RL-SV2S is a dual slope laser. It has a screen on the front. It will slope up to 5% plus or minus in both axes. The laser must be set to the direction of the grade setting. In the layout part of this training, we will go over terminology and abbreviations, layout strategies, cut and fill, string lines, and measurements. Terminology and abbreviations. Finish grade is the top surface of an area after construction is complete. Subgrade is the surface you build up from for construction, usually soil. Subbase is the layer of material on top of the subgrade, which is not always necessary. Base is the layer of material on top of the subbase and directly underneath the slab. Offset is a supplementary line close to, usually parallel to, a main survey line to which it is referenced by measuring offsets. Elevation, the vertical distance relative to a reference point, usually sea level. TG is top of gravel. Layout strategies. When setting layout stakes, follow these guidelines. Be consistent with your staking. Offsets should be the same distance away from your feature, as well as staggered a consistent distance apart from each other. Flag or paint the top of your stakes to add visibility. Make sure your stakes are sturdy so they don't move easily when machinery drives close to them. Write clearly so others can understand it. If a stake gets knocked over or broken, don't just stand it up back in place as the grade will have changed. Cut or fill. In order to show finished grade when it is too high or too low for the grade stake, you write a cut or fill on the stake. You always measure cut and fill from the top of the stake. If finished grade is 1 meter below the top of the stake, you would write cut 1.0 meters FG, or finished grade. If finished grade is 30 centimeters above the top of the stake, you would write fill 0.3 meters FG, or finished grade. String lines. String lines are used to mark out a straight line, find level or slope between 2 points, or lay out a geometrical shape. Things to consider when using string lines. The string line must be pulled quite tight to accurately achieve the desired elevation. Measurements. Area. Use area to find the amount of space inside a geometric shape. To find the area of a square or rectangle, you multiply length by width. To find the area of a triangle, you multiply half of the base times the height. To find area of a circle, you multiply pi, the radius squared, that will give you the area. Volume. Use volume to find the amount of space inside a three-dimensional geometric shape. To find volume of a cube or rectangular prism, you multiply the length by the width by the height. To find volume of a cylinder, you multiply pi by the radius squared. That will give you the volume of a cylinder. Pythagorean theorem. Pythagorean theorem is used to find the length of an unknown side of a right-angled triangle. How do we use it in construction? When laying out a right-angled triangle, use Pythagorean theorem to ensure the angles are correct. When laying out a square, use Pythagorean theorem to ensure the square is square. Site strategies. Planning your site. It is very important to plan ahead when deciding where to put certain things. A sea can, gravel or material deliveries, topsoil stockpiles, and GPS poles are some of these things. When deciding on locations for the above, look for sewer pipes to be installed, sewer structures to be installed, proposed planting, and try not to block access when hard surfaces are installed. Looking at this drawing, we look at the structures as well as where the pipes are going in between structures. The yellow lines are the pipes and the structures are at the end of each yellow line. We've decided where the topsoil pile, the gravel stockpile, and the sea can will go by looking ahead on the drawing and making sure there's no conflict. Water management. Standing water can be a major issue when working in construction. If planned poorly, one rain day can turn into multiple days off waiting for water to dry. Best practices for water management are: know where you want to push the water in the event of a heavy rain. Limit the amount of space that limits water flow, for example, holes, large depressions, blocked flow due to material piling. Backdrag rough ground prior to rain to allow flow. If need be, dig swales or holes to allow water to flow into for pumping after rain. Thank you for participating in this training. Please proceed to the test in the task section of the training site. Good luck.